Before I start, can I just quickly get like a quick understanding of what the what kind of audience we have, like what is the expectation from the audience actually? Okay, so then what we'll do is we'll just start the session, and towards the end of the session probably we'll take the question answers. Okay. Okay. So just a quick introduction to Royal Cyber. This is what we are going to do from the agenda point of view. Get an introduction to the Royal Cyber, about the company, what we do, what kind of services we offer. Then we'll talk about the need of an application integration from a solution point of view. What's an ESB? What is a message broker? Where does it fit? What are the different constructs in message broker? Then probably what are the other middleware products which falls into the same category. We'll look at those, and then probably we'll look at one of the case studies, and then we'll have a demo on this actually. Okay. So the quick introduction on the company. Royal Cyber is a company based out of US actually. As an IBM business partner, primarily serving WebSphere customers actually. We do all kind of middleware technologies. So we kind of focus on the middleware technologies, primarily on WebSphere products. We provide solutions on a wide range of brands, and also from the middleware point of view, we kind of do WebSphere MQ, Message Broker, ESB, and Data Power. Apart from that, we also cater to the Lotus brand, that is the portal database, DB2, and some of the rational tools also. And also we are also kind of business partner for Microsoft also. Some of the services we do on the Microsoft as well. Okay, as I told you, we are IBM business partner, and also we are authorized training partner for IBM for WebSphere products actually, and also we are gold partner for the Microsoft. Okay. Need for an application integration solution. So primarily, why do we actually need to kind of require an integration? When do we actually need it actually? Generally, when you have a challenge in the sense, like when you have an application, probably an application which is sometimes it's mostly a legacy application, or even the newer set of applications as well. If these applications needs to be exposed as a web service, or needs to be exposed or integrated, requires to be integrated with wide range of other applications, right? Generally what happens is in an environment, you will actually kind of develop an application, in-house application, which will try to integrate these systems from a point-to-point kind of a analogy actually. So probably to resolve a connectivity issue, you would end up building a simple application which will actually kind of do a point-to-point and exchange information between them. And from a enterprise level, if you start doing that, you will end up having lots of these applications which are connected to each other from a point-to-point kind of a analogy actually. So then it becomes too cumbersome actually. Once you have that kind of a application, an architecture, it becomes tightly integrated interfaces. So you change something else will get broken, and so it'll be too rigid also to kind of make any changes actually. So in those scenarios, sometimes even the business logic is completely embedded, and then reusing of certain business logic becomes really very difficult actually. That's when we actually kind of suggest you to move on to an architecture called a service-oriented architecture. service-oriented architecture basically enables the creation of like modular, a smaller set of applications, which could be a new set of applications or which could be an existing set of applications, basically primarily built on some open standards and available standards actually. So service-oriented architecture provides a set of like business-aligned services that can be combined to fulfill the business goals. Uh, Primarily, basically, once you start getting into that kind of an architecture, once you start thinking in those lines of those architecture, you will start seeing applications as services actually. Suppose you have an application within a mainframe, and probably generally the applications which are built on mainframe are quite robust actually, and the customers tend not to move away from that because it has been serving for them for quite some time. It's being stable for a lot of reasons, and they don't want to discard it, right? And there is no point in rewriting that entire set of applications also actually. In those scenarios, reusing those applications becomes the biggest challenge there. Challenge in the sense, if you reuse, that's the advantage. Basically, you will actually kind of make use of the existing legacy applications so that you can bring them to on the web. You can make them available over the web, or make them available to be interacted with a newer set of applications, maybe a web application or an ERP application, right? Or even a smaller set of applications also. To enable you to do that, that's where the concept of the services will come into picture. To do that, you need to come out of this architecture where all applications are talking to one another actually. So once we identify and bring down a set of interfaces which are common, and then you can actually decouple them, then you will actually move to the next level of the integration. So the first level of integration is breaking that the mesh where you have the interfaces which are interlocked with each other to more of a simple hub and spoke kind of an architecture actually. So to do that, probably the first level of integration would be like an enterprise architecture integration, where all the applications would be talking to a common layer called a bus, where the bus will identify the kind of the request that it is coming, the kind of messages it is receiving. Based on the type of the message, it will like transform the message, route the message, kind of do certain where it decouples the existing set of applications from which are tightly coupled to each other. So which becomes even much easier to manage, and also it becomes much easier to bring in when there is a business change. It's easier to bring in a new set of applications and then add it to the hub, rather than adding interfaces across multiple connectivities across multiple interfaces actually. Okay, the product which does that kind of a feature is the ESB. ESB is the enterprise service bus, primarily which does like a predefined set of functions, primarily to decouple the existing set of applications and then kind of manage these applications through a common hub actually. IBM has a set of products which does this functionality actually. The foremost one, the first level of the ESP is the WebSphere ESP, which is based on the J2E technology. That is primarily focuses more on the web services based applications actually, integrating web services based applications. Then there is another product called WebSphere Message Broker, which is called as an advanced ESB, which kind of is the reason why they call it as advanced is because it can do any to any kind of a transformation. It can connect to between any kind of an applications. It can do transformation from any format to any format actually. And the third product is more of a device, which will actually which kind of enhances the web services security. It kind of enhances the speed of processing of XML transformations. Is the data power actually? It is a device based server which does the transformation at a very high speed. That is, it transforms messages at wire speed actually. So there are three different offerings based upon the requirement. We will actually project that particular product actually. Okay. So primarily here we're going to talk about WebSphere Message Broker actually. Okay. So generally a WebSphere enterprise service bus is nothing but a flexible connectivity infrastructure for integrating applications and services. These are the tasks that an ESB performs. Like it routes the messages between the services, it converts the transport protocol. Suppose you have a legacy application on one side and you have a open systems on one side. Legacy application uses a protocol called LU6, and then on the other side probably TCP, right? So in those scenarios it kind of transforms the protocols as well, and then it transforms the message formats. One side you might have a COBOL copybook, on the other side you might have a XML based messages, so it can do the transformations across that, and also it kind of handles the business events also to a certain extent actually. Okay. So ESB gives SOA its full value. That means, so it kind of turns this ESB into common interface, like a common enterprise service bus, which will handle all the requests from the services and kind of decouples all these services from like interacting with each other directly. So now the services can have to just kind of interact with the bus itself. So IBM Message Broker falls under this ESB category actually. It's called as advanced ESB. So it's built for universal connectivity and then performs the transformation in a heterogeneous environment. Basically, why it's called an advanced ESB is it can do any to any kind of a transformation, transforms messages from any format to any format. It supports wide range of formats, wide range of applications, and also it does the transformation at a very high speed, almost 10,000 messages per second actually, and it is available on multiple platforms actually. Basically now it is supported on wide range of platforms as well. The kind of protocols that it supports, you can actually see them from an WebSphere MQ to you have like a mobile devices, you will have telemetry devices, real-time devices. You can also have integration with enterprise applications like SAP, Oracle Apps, JD Edwards, and other industry standards like HTTP, FTP, TCP, SMTP. So it kind of supports a wide range of protocols actually. So when a message is coming on one side, you might have an application which is MQ based application. On the other side, you might have a TCP based application. It can read the messages from a queue, transform the messages to the target format, and then send it out to a TCP IP as a packet, or you can put it on FTP on a file also. So that kind of transformations can be done using the broker. Okay, broker has two different like broker has three different products. With WebSphere Message Broker has like within broker, when you buy broker you get three different products actually. One is WebSphere MQ, the second one is Message Broker Runtime, and also you will get WebSphere Message Broker Toolkit actually. Toolkit is the product which is based on Eclipse, which is meant for developing the applications actually. So you can actually develop the Message Broker applications on the toolkit, and then you can build it and deploy it onto the runtime. The kind of applications which you build, basically you will build two different sets of applications. One is called message flows, and the other one is called message sets actually. Message flows is nothing but it's equivalent to any kind of a program. Generally in languages, any language you pick, you will write a program based on that language. Suppose you have Java, you write a Java program actually. Here we build applications using visually drawn programming. It's basically visually drawn program where you have a set of predefined set of nodes and you drag and drop onto your palette, and then you do the connectivity between them, and then you can write certain scripts behind that actually. So here you can actually see a picture of a message flow which provides the processing sequence. That means it picks up the message from a queue and writes it to a file or invokes a web service actually. So based upon the type of the customer, here it's a message flow based upon the type of the customer, you will actually kind of either route it to a web service or write it to a file actually. So it will have a set of input and output nodes, and it will have a processing nodes. So all this is visually drawn and then developed and then deployed onto the runtime. The focus more on the development is very much easier when compared to any other programming language actually. So the time you bring, suppose if there is a new service that comes into the enterprise application, the time to bring that service online is much lower when compared to building other set of applications using different languages actually. Okay. So it's easily, you can extend, the extensibility is very much easier here in the broker, and also the flexibility. The flexibility, basically it gives you an option to, without changing your existing set of applications, you can kind of, without impacting either the source or target, you can keep changing the underlying ESB here. Here are some of the nodes which we use for the development purpose. You can see it's been categorized as WebSphere MQ, JMS, HTTP web services. These are all the set of the different nodes which can be used for like the different sources or target applications, and different types of routing mechanisms which can be used, and different transformation mechanisms which can be used. So all of this are actually part of the palette actually. So on a message flow, you will actually kind of pick certain input nodes, output nodes, processing nodes, and you kind of build a flow actually. Okay. So these are the different types of nodes, like an input nodes, output node, processing nodes, protocol specific ones. So these are some of the nodes which you would be kind of using there. Now, if I go back a slide here, like you have set of nodes actually. You have set of input nodes and output nodes. Here when I say HTTP input or SOAP input or an MQ input, that node will receive a set of messages actually. If it is a SOAP input node, probably it's expecting some kind of a SOAP message. If it is an MQ input, probably different. It could be anything. It could be an XML message, or it could be COBOL message, any message. But how does this node would understand the type of the message that it's receiving actually? Behind every node, there is a property which we set for kind of understanding, basically set it to a predefined set of formats actually. Here it's called as parsers. We have a set of parsers which gets invoked when the message lands on an input node. So the input node with reference to a specific set of parsers and parse the message. Once it parses the message which is in more of a bit stream format, or what we call it as a wire format, gets converted into more of a logical format. This transformation, basically the first level of parsing happens at the input node. So input node converts that message into this logical message. The logical message is an internal structure to a message broker, okay, where the entire message is treated as a logical message until it is sent out of the flow, out of the broker actually. So from a transformation point of view, it becomes easier to interpret the logical message than as a physical message, because physical message has lots of formats. One could be XML, COBOL, comma separated values. So it's hard if you start representing it as a physical message. So that's why broker converts into a logical message, and from the logical message it can convert to any other format actually. Okay, so target format will be more of a logical message, and then once it is sent out of the node, it becomes a physical message again. Okay, to do that, so here is a representation of a physical message and the logical message. The physical message is probably, if it is an XML, it is a self-defining message where you can read through that, like you have an order, name, first name, last name, everything. Once it is kind of parsed into the broker, it becomes a logical message actually. Okay. Apart from this structure, it has lots of other headers. Probably at this point in time, it's too much to get into. There are headers like root, environment, local environment. So many of these headers are there. But ideally, what happens is it gets converts into something more of a logical message here. Okay. How does it gets converted into a logical message? There is another set of applications which we need to build called message sets and message definitions actually. Message sets is another set of construct. Basically, it's more like a repository or a dictionary where it stores the different formats or different types of the messages that we are going to expect from the input message. So suppose I'm expecting a COBOL message. I use the COBOL copybook to create a message type, a message definition, and that is interpreted, that is referenced at the input node. When the input node receives a COBOL message, it automatically kind of refers to the message set and message definition, validates against the message set if it is a valid message or not. If it is a valid message, it gets converts to a logical message. If it is not a valid message, it throws out, it sends it through the failure terminals. So this becomes the backbone for the message flow, message broker development. Basically, the message broker message flows reference these message sets for passing the messages to various formats actually. Okay, so primarily these are the two areas where you do the development. Okay, so the message transformation is conversion of message from one format to another format actually. So to do the transformation, you have other various set of nodes called transformation nodes. Some of these nodes would require you need to write a script or a programming language behind it, or some of them doesn't need it. Like the mapping and XSL transformation nodes, we don't need to write any kind of a programming. Mapping is a visually drawn mapping transformation node. XSL is more where you provide a style sheet which will automatically transform an XML from one format to another format. Compute node, you need to write a program based on a language called ESQL actually. So where you do the transformation using programmatically. And then Java compute node, they have given support for using Java to do the transformation, because ESQL is not a well-known language. So since Java is being widely used, they have also introduced the compatibility with Java. Okay. So generally, this is how a broker will do the transformations. So you have a broker runtime. You can see that there is a BRK1, that is the broker runtime where the broker runs. On this broker, you actually deploy these flows along with the message sets and message definitions. Once you deploy the flows, Suppose if the flow has an MQ input node and an output node, it would start monitoring the queue for any kind of messages. Once an application A puts a message onto a queue, the flow picks up the message, it does the routing based upon the content of the message, does the transformation, and then finally puts the message onto a queue again using this MQ output nodes. So that's how the broker kind of does the transformation of messages or integrates applications which are running on different platforms as well. Okay, so basically it receives and routes the message, transforms the messages, and also selects the message for further processing, like to go to kind of enhance the message content. It can also integrate with databases. It can actually look up another set of queues. So it can invoke another web services, get the information. So it can do lots of integration here within the broker actually. Apart from the standard integrations, it can also kind of integrate with other products also actually. Suppose you deploy a web services application on the message broker, and you want to provide security for those web services. We can bring in another product called Data Power Appliance. So this appliance can enhance the message flow by providing security on top of the broker actually. So that kind of integration can be done using the broker and other products. Okay. So that's kind of a high-level introduction to broker actually, and then the broker can be monitored using different products. There are two different products. One is Tivoli ITCAM, another one is called Business Activity Manager. Tivoli ITCAM, basically both of them from two different brands does almost a similar set of monitoring actually. Primarily to monitor different kinds of flows, their statuses, like whether the flows are running or not, what kind of a performance it's giving, basically kind of gives the statistics like how many messages are being processed. So all that information can be monitored here on the monitors actually. So basically you can view performance. Basically it gives you a visually layouts actually, like the graphical layouts on the tool. The other middleware product, basically these are some of the services which Royal Sabre provides actually. Provide services on wide range of WebSphere products, which includes MQ broker and message broker, and then data power. From an MQ point of view, we provide services right from the initial stage, that is basically installation, configuration, to deployment, setting up the development environment to production environment, production being in a clustered mode. And also we do the health checks, we provide support from the administration supports, and also we provide the troubleshooting, and also we'll do the training as well actually. Okay. So from development broker, almost similar set of services. From development point of view, we do the analysis, requirements gathering, design, developing the applications, deploying, building the applications, and then creation of the enterprise architecture, basically the deployment servers. So we can do the performance and monitoring. So wide range of services are also available on the message broker here. And similarly, we also provide the services on data power, from the installation of the device to configuring the device for web services security, the integration with other products, and also do the transformation, development, support, the performance and tuning, or also the services which we provide here on that. Okay. A quick look on one of the case studies actually. Here The customer here is a distribution company based out of North India actually. They have a wide range of stores in wide number of locations actually. The primary need here was basically as they started growing, their applications become too hard to manage because they start introducing newer applications to solve some business needs, and maintaining those applications or integrating those applications with the legacy system or the front end of web-based application which is built on commerce, and also need for integrating with the payment gateway. So they have a need where they, if one of the payment gateway is already configured and for some reason they want to change it, right? It should be easily, it should be flexible enough to kind of switch over to different payment gateways actually. So their business needs keep changing and new needs keeps coming up. So their old legacy applications couldn't keep up with the kind of integration actually. So whatever the applications which they built to integrate the small applications couldn't perform, or basically where it couldn't was not stable enough actually. So in those scenarios, what they have done is they have moved to more of an SOA kind of an architecture where they brought in the message broker to do the integrations through an enterprise-wide hub, where all the messages, all the integrations within their enterprise level, the applications within their enterprise, will actually get routed through the broker. Broker will ensure that any other application, that is, suppose if the commerce is the front end application which will actually need to kind of integrate or talk to a payment gateway, it will actually get routed through the broker. Any kind of orders that needs to be placed will go through the commerce. From commerce it will get goes through the broker. Broker will actually integrates with the legacy application and also the ERP solution. So basically it kind of does the integration between all these different systems. The messages, the type of the messages which goes back and forth, a wide range of messages from XML to COBOL, web services based messages. So broker kind of does all the transformation, routing between the set of applications actually. So just in case if they wanted to change, introduce a newer payment gateway, it's much simpler and it's easier. Basically, all they have to do is kind of change the target path or the endpoint information on the broker, identify the structure of the message, and build it, deploy it, and then you can actually kind of have the new payment gateway integrated. So with the minimal set of application changes, you can actually kind of integrate or bring in new services actually. That's the goal behind the broker. That's how they're kind of using it in those scenarios actually. Okay. So probably I'll just stop here and we'll have a quick demo actually. What I'll do is I'll quickly kind of show you one small demo and then I'll hand it over to my counterpart Sunil actually, who would actually show you a much bigger demo where it integrates with WSSR, data power, broker, and then the various products actually. Just a quick demo on how a very simplest demo which I can demonstrate is basically this is what is the toolkit which I was talking about, where you will build two sets of applications. One is the flows and other one is the sets actually. So I'll just quickly show you how a message flow looks like. This is the simplest message flow. What I'm trying to do here is, well, I actually kind of trying to transform a message from one format to other format. So basically right now I have a message which is in a COBOL format, okay, which is more of a wire format. You can actually see the structure of the message here. This message will use this message, basically transform this message to more of an XML format actually. Okay. So this is the structure of the message. Since it is a COBOL copybook, which is a fixed length, you will see more of a wired format one. So once we put this message onto a queue on the broker, so the broker has the name of the queue where it actually needs to kind of look for messages. The moment you put a message on this, these parsing properties will intercept, and then it'll try to parse the message and sends it to the compute node in a logical format. Once it is in the logical format, the compute node transforms to XML format and then puts it to an output node, which again becomes a physical format actually. So I'll just put the message onto the queue. Okay. Now, since it's a very high speed, the entire thing happens within no time actually. So the message will be put onto the queue, the broker reads it, transforms it, and puts on another queue. So what I'll do is I'll try to see if the message is on the output queue. We'll just say read queue. So once you read the queue, you have this message. So if you compare these two messages, so one is in a fixed length format, the other one is in a XML format. All I have done is just change the format only, but the data is still the same. You can see the version as 2 here, version as 2. You can see the name first, name as Ed. Here is the Ed. Since it's a fixed length, you will actually consider this as the first name. Then the last name, Fletcher. You can see the Fletcher here. So similarly, it kind of does the transformations. Right now we are seeing the transformations happening from the COBOL copybook. Let me just import the copybook also, so you can actually see that message. See, this is the copybook on the left side. You can see the values on the right side here, right, which got transformed to more of an XML format, which is a more of a human readable format actually. And if you look at the code, there is a minimal set of code, a program which has been done here. This is just the code which has kind of did the transformation actually. So the main part is basically this input node doing the parsing, and the output node will convert it to the target format. Okay. So now what I'll do is I'll hand over to my colleague Sunil actually, who will actually show you a much bigger demo actually, basically wider products actually. Sunil?
Hi, in this presentation we will see the integration of WSR, Data Power, Message Broker, iLog, DB2 and SOAP UI, which is working as a service requester here in this particular service. So the objective for this service is the demonstration of a user sign-up service which is secure, robust, easy to modify, loosely coupled, protocol independent and scalable. Which is purely based on the SOAP architecture. So let's have a look on the high-level diagram for this particular service. Basically, we can divide this service in two domains. The first one we can say is a requester domain, and the other one is a provider domain. In requester domain, we have SOAP UI, which is working as a request initiator. That is from where we are basically sending the request. And in provider domains, we have couple of components which are integrated to get the required scenario successfully completed. For example, a data power where we have implemented a web service proxy, which is basically validating any incoming request, and which is also subscribing to WSR, where the visual file is published, and after getting that visual file and validating the request, data power forward their incoming request to the message broker. And in message broker, where basically our core business logic is implemented, and where the WMB application is up and running, which is further communicate with the iLog for business validation. And final all these validation stuff, information is inserted in database. Here in this service we are using DB2 for this particular purpose. So this is the service processing, which is described step by step, which is basically initiated by sending a SOAP request to data power from SOAP UI, which is acting as a service requester as described earlier. Then data power receives this request, subscribe to WSRR, and validate the request against visual file, which is published in WSRR. And once the request is validated, data power lookup for endpoint URL in visual file retrieved from WSR and forwarded to the message broker. Once the request is received at the message broker, WMB generates a request message for iLog and waits for the response from iLog. If iLog validation is true, then message is forwarded for account creation, and then message broker processes the request, which means it extracts the sign up info and insert in database in DB2. After insertion, WMB create a response for request, which is processed and replies back to the data power, where data power again validate the response message and finally display we can see and SOAP UI. If, for example, first let's see, if iLog validation is false, then error message is generated and sent back to the data power, thus following the same same path as the request was coming. And finally response is again validated, again visited schema, and finally sent back to the front-end client system, which is request initiator. So let's have a look at the component wise. For example, at WSR we have this WSDL, which is published over there, and this is the tree for the WSDL file. Moving on, we have data power, and there we have three components that we have implemented. For example, we have WSR server object, where we are basically this is where we give the information for communicating the data power with WSR. And once that is done, then the second option is allowing the HTTP traffic to the data power. After these two components are implemented, then finally we are able to create the web service proxy service, where the core business logic for data power is implemented. In iLog we have decision table created, and where basically we are checking for cities and their authorized account types. For example, if city is New York, then only a special account type and regular account type are permitted, and that is only this that makes the success scenario for this particular city and account type couple. And moving on, finally we have message flow in message broker and the schema for this particular table. Here to the have a look at the sample request that we are using for this service, and this is the expected success response that we should get if everything is fine. And likewise we should see the all the data should be inserted in DB2. So let's move to the demo now. Let's start with the SOAP UI here. Okay, from here we are basically sending the request. Here, as you can see, we have predefined schema for request. Similarly, once when we see afterward, we have also a predefined schema for the response as well. So here we are basically checking for the we are sending the account ID, customer name, and the account type, email ID, and etc. That's a typical account creation scenario. So here basically the checking point we should note here, or the one is the schema validation point, schema validation that is done at the data power end, and the other validation is done at the iLog, where we are basically checking the account type and its associated cities. So let's make correction here. Okay, so before running this request, let's have a look at the each component. For example, here at data power, this is a service that we have implemented for uh, this particular demonstration. Here we have given the all necessary information, like for example the visual file that is published over WSR and its name spaces and some of its attributes. Similarly, here we have ilog, where we have created some orchestrations and decision tables. Here, as you can see here, that this is a decision table where basically we are checking for these cities and their associated account type. Say for example, Los Angeles is only permitted for the standard account type, and for example account type super it is okay with all kind of cities. So that is true for all kind of cities. Similarly, here we have message flow deployed at message broker, and here we are basically getting the request, HTTP request, and at this node we are creating a request for ilog, where we are sending the couple of account type and cities, asking the ilog if this particular city and account type is okay or not. So here we define the communication points for ilog, and once getting the response back from the ilog, we are checking here either ilog has succeed the request or not. Then if the ilog has sent us a success message, then that message is sent here at this node, where we are basically creating the account. That means we are basically extracting the information that is coming with the request and inserting that data in the database db2. And finally here we are creating a response message that is sent to the data power, and that we will see ultimately in the SOAP UI. So, and again, suppose if the ILO validation is failed, then here we are creating the error message that is sent to the data power, and that message also we will see later on in SOAP UI. So time to run the request. Since account ID is the unique ID, so we need to make sure it is unique. Okay, so let's run it. Here it's saying that thank you, your account has been created successfully. That means this data should also be inserted in database. So let's check if this data is inserted now or not. Account ID 5, account ID 005, that is inserted. The request, that means this service is working as per our scenario. Now let's run couple of failure scenarios and see all our validation is working or not. Let's start validation from the data power perspective, that is the schema validation. So that means if we change the schema here in the request, it should pop up with the error saying that okay, this is the error, and data power will not allow that request to forward to the message broker. So let's just make a little change here, change anything here that should cause change here. Okay, it should throw an exception and say that okay, this is validation error, schema error better to say. Make sure ID is unique. Now send it again. Okay, saying that it's internal error, that require this exception is basically sent from the data power saying that okay, the schema is invalid. That means okay, so that is working. That means our data power is working fine. Now we should move back, move to the ilog, saying seeing the here account type and city, that is the pair that we are basically validating in ilog. so it's working or not. So if we change here in Los Angeles anything that is not in our decision table, and for that standard account type is not defined, then it should pop up with an error. So let's again change here and see if this validation is also working or not. Okay, again we need to change the account ID, make sure it's unique. Okay, so here we are seeing that, okay boss, this is ilog, we are sorry, account creation for a specified city and account type not specified at the moment. That means ilog validation is also working as per our scenario. So that's all from my side. So any questions so far?